In example 4, we're asked to solve the equation using the quadratic formula. But before we do that, let's get the equation into standard form. And also, to make things easier, let's clear all fractions. So let's multiply every single term by 10, the least common denominator. So 1 times 10 is 10. T over 5 times 10 is 2 times t. And t squared divided by 2 times 10 is 5t squared. Next, let's move all of the terms to the side of the equation where the t squared coefficient is a positive number. So I'm going to add 5t squared and subtract 2t from both sides. And now we can plug into the quadratic formula. So t is equal to the opposite of b plus or minus the square root of b squared. And I would suggest going ahead and doing the squaring in your head. Negative 2 squared is 4. Minus 4 times a times c all over 2 times a. Let's do a little simplification. Inside the radical, we have 4 minus 200, which is negative 196. And in the denominator, we have 10. So let's do a little bit more simplification. T is equal to 2 plus or minus the square root of negative 196 is 14 times I, and divided by 10. And so what we want to do now is factor that 2 from the numerator, 1 plus or minus 7i, and then factor a 2 from the denominator, and then divide out those common factors, and our t values are 1 plus or minus 7i divided by 5. Or if you wish, you can write your answer as a solution set. 1 minus 7i over 5 is one solution, and 1 plus 7i over 5 is the other. This could also be written in a plus bi form, 1/5 minus 7/5 I, and 1/5 plus 7/5 I. There are lots of options for ways that you can write your answers. In B, we have another quadratic equation, but it's not in standard form. So let's multiply the two binomials together. So x squared plus 7x plus 2x plus 14 is equal to 4. And then we're going to move it into standard form by combining like terms and then subtracting 4, which will give us x squared plus 9x plus 10 is equal to 0. Next, we can plug into the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Let's do a little simplification here. In the square root, we have 81 minus 40, which is 41, and then divided by 2. And that's a fine final answer since the square root of 41 does not simplify. If you wish, you can write your answer in solution set form. Negative 9 minus the square root of 41 divided by 2, and the second solution, negative 9 plus the square root of 41, all divided by 2 as well. Now here's one for you to try. Try C and pause the video while you do this. For this one, you should have gotten negative 3 plus or minus the square root of 11 as solutions. And it's important that you clear fractions first before doing anything. Do be careful about what is inside the radical in the quadratic formula. When we have two negatives multiplying together, that's going to give us a product that is positive, so it's actually 36 plus 8. All right, and when we simplify, you want to simplify the radical first, and then factor out any common factors and reduce. Now pause the video while you try D. This exercise was just a little bit different, and what makes it different is that we got rational solutions. When there are rational solutions, and you're going to notice those because you will have a perfect square under your square root in the quadratic formula. When you have those rational solutions, it is important that you separate the operations and actually do the adding and subtracting that's specified, since we have like terms. 1 plus 5 divided by 4 is 6 over 4 or 3 over 2. 1 minus 5 over 4 is negative 4 over 4, which is negative 1. It's important that we simplify the solutions all the way. What we have been finding so far are what are called exact solutions. Exact solutions are not rounded off. The TI Nspire will allow you to write an expression that can be evaluated all at once rather than one operation at a time, and for these we can find an approximate solution. So, some important things that you need to know how to do. In order to enter a fraction, you are going to press Control and then divide. That's going to allow you to enter a fractional expression without putting parentheses around the entire numerator. To enter a square root, Control and then the square key. To move the cursor within an expression, just use the arrow keys in that touchpad, around that touchpad. So we're going to do some examples here, finding an approximate value of each expression and round to the nearest hundredth. To enter the expression in example 5a, we need a scratch pad or calculator page, and you can press the home key in A if you wish, or you can open a new document, whatever your preference is. In order to enter this expression, we're going to press Control and divide to get a fraction, and then negative 3 plus the square root, so use the squared key and the Control key before it, 641, and then cursor down to get to the denominator, all over 7, then just press Enter, and to the nearest hundredth, that would be 3.19. Let's try one more similar example. To enter the expression in B, Control and divide to get a fraction template. Then for the numerator 5 minus the square root of 83, cursor down for the denominator, over 4, press Enter to round it to the nearest hundredth, that's negative 1.03. What's important to note here is that we don't really need to do any simplification if we're going to use the quadratic formula to find approximate solutions. So, in example 6, we are going to solve using the quadratic formula and round our solutions to the nearest hundredth. So, this is already set up for the quadratic formula. The very first thing I'm going to do is write down what I am doing. Don't do it all in the calculator. Something must be written down. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Once we have all of that entered, it is fair to use the calculator to evaluate each expression. Now it's important to remember that there are two expressions to evaluate. One has a plus sign and one has a minus sign. First, I'm going to enter the expression with plus. So Control divide for a fraction, and on the top, negative 4, and then plus. There is no plus or minus key. The square root of 16 minus 4 times 5 times negative 2, all over 2 times 5. And then you could just press Enter and round it to the nearest hundredth. We get 0.35. Next, I'm going to enter the very same calculation, but this time with the minus rather than the plus to give us our second solution. Rather than entering the entire expression again, I'm going to use a little calculator trick. I'm going to use my cursor up button to grab the calculation that we just did, press Enter once it's highlighted, and now I'm going to cursor over with my left arrow key and then delete that plus sign and replace it with a minus sign and then press Enter. That will give us a solution of approximately negative 1.15. All right, there below we have a try this one and round your solutions to the nearest hundredth. Be sure to write down what your work is. All right, check your work. You should have gotten two solutions, negative 0.77 and positive 0.43. The next few examples, we're going to be working some word problems, and in some cases, the solutions may need to be rounded, so we may use our calculator. A ball is thrown upward with an a height in feet given by the equation h is equal to 80t minus 16t squared, and t is the number of seconds since the ball was thrown. When is the ball at a height of 80 feet? So that means that if we use our equation, h is equal to 80t minus 16t squared, that the variable h can be replaced with 80 feet to represent the height of 80 feet, and that we can then solve the equation to find the value of t, or time, since the question asked when. So I'm going to simplify things a little bit for myself. Just in terms of working with the numbers, I'm going to divide everything by 16. If I divide by 16, we get 5 is equal to 5 times t minus t squared. And then I'm going to add t squared, subtract 5t, and keep 5 where it was. And then we can use the quadratic formula in order to solve. So t is equal to the opposite of b plus or minus the square root of b squared, which is 25, minus 4 times a times c divided by 2 times a. And that is enough that we can enter the results into the calculator from here. For my first solution using the plus in the quadratic formula, control divide gets us a fraction. The numerator is 5 plus the square root of 25 minus 4 times 1 times 5 all over 2 times 1. And that gives us a value of 3.62. And now I'm going to do the same computation with minus. Grab that calculation that I used with plus by cursoring up, and then delete the plus and change it to minus, and we get 1.38. And this tells us that the ball is at a height of 80 feet, 1.38 seconds, notice that units were included, and 3.62 seconds after it was thrown. That makes sense because the ball is at 80 feet when it's on its way up, and then again when it's on its way back down. In B, a swimming pool is 6 meters by 10 meters and surrounded by a walkway of uniform width. So an aerial view of the swimming pool might look like this, where we have that pool that is 6 meters by 10 meters, and the walkway is the same width, which I'm going to call x, all around. So in this case, they're telling us that the area of the walkway is equal to the area of the pool. We know that the area of the pool is 60 square meters, since it is 6 by 10, and the area of the walkway, which is pictured in gray in this diagram, is equal to the area of the outer rectangle minus the 60, which is the area of that pool. So we're just looking for the area of that gray region, which is that frame around the pool. The length of the pool is comprised of 3 smaller lengths: x, the width of the walkway; 10, the width of the pool, or the length of the pool; and x, the width of the walkway. So when I add those together, that means that the length is 2x plus 10. Similarly, the width of the outer rectangle here is 2x plus 6. So the area of the walkway is 2x plus 6 times 2x plus 10, the width times the length, minus 60. And if we multiply that out, that is 2x times 2x is 4x squared. And the product of the outers is 20x, the product of the inners is 12 times x, and the product of the last is 60. If we subtract 60 off from that, then we'll get 4x squared plus 20x plus 12x. And we were told that that is equal to 60. I'm going to divide by 4 so that we get x squared plus 5x plus 3x is equal to 15. So we get an equation x squared plus 8x minus 15 is equal to 0. As it turns out, this expression here does factor. I'm sorry, the expression does not factor. And so we're going to use the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared, which is 64, minus 4 times a, which is 1, times c, which is negative 15, all over 2 times a. And now I'm just going to write all of that in my calculator. We'll use control divide for the fraction, and then enter the numerator, negative 8 plus the square root of 64 minus 4 times 1 times negative 15, all over 2 times 1, which is 2. So that would be using plus, and using plus we get 1.57. And if we want to do the same calculation using the minus, re-enter the entire calculation, cursor over, change that plus to a minus, and we get a negative number, negative 9.57. We're going to need to see both of those solutions, and then we know that a negative solution for a length is not valid in the context of the problem. So that means that our final answer here will be 1.57. I'm going to place the decimal point in the right place here. 1.57 meters would be our final answer. But we do need to see both solutions. In the next example, a rectangular feed has an area to 2,400 square yards, and it's enclosed by 400 yards of fencing. So fencing, the length of the fencing really represents perimeter, whereas we are told about the area. So that should be enough information to find the dimensions of the field. I've drawn a picture here so that we can visualize 4 sides, and 2 of the sides labeled X, 2 of the sides labeled Y, and we do have some information here that there are 400 yards of fencing, so X plus Y totals to 400, or 2x plus 2y totals to 400. That everything here is divisible by 2, so let's just go ahead and do that to simplify. And so that means x plus y is equal to 200. Well, that means if we solve for y, y is 200 minus x. We're just going to hold on to that piece of information. Then our other information here is that the area is 2,400 square yards. So the area is the length times the width, and our width is x, and our length is, now we have found out that it's 200 minus x, and so that should equal 400, I'm sorry, not 400, but 2,400 square yards, the area that's specified here. I'm just going to go ahead and distribute the multiplication. 200x minus x squared is equal to 2,400. And then move all the terms to the same side of the equation. It is generally easiest if we move terms to the side of the equation where the x squared coefficient will be a positive number. All right, let's use our quadratic formula. X equals the opposite of b plus or minus the square root of b squared. So I'm just going to write negative 200 squared. If you're going to write that squaring in your calculator, you be sure to use parentheses. Minus 4 times a times c all over 2a. And now we need 2 solutions, one with the plus and one with the minus. Control divide for a fraction. Numerator is 200 plus the square root of, and if you don't use parentheses here for the squaring, you'll get a wrong answer, so be very careful. We want to square the negative 200, not 200, and then take the opposite of it, minus 4 times a, which is 1, times c, which is 2400, and then that's all over 2. So we get 187.18, and then our second solution may be found going back and editing that earlier solution and exchanging that plus for a minus, and we get 12.82. Well, remember, that's the value of x, so we actually just found the width of the rectangle. Remember that the length is 200 minus that value. So if our width is 187.18, then our length is 200 minus 187.18, which is 12.82. And it turns out that if our width is 12.82, then our length is 187.18. In this case, the solution gave you both the length and the width. That doesn't always happen, so beware. So the dimensions of the field are 12.82 yards by 187.18 yards. In our next example, two hikers start from a point of intersection of two straight roads that meet at right angles. So Bob is going to walk at 2 miles per hour along one road. So let's have Bob moving east, and then Bob will end up here. 2 hours later, Kathy starts walking at 3 miles per hour along another road, so she's walking a little faster. She may get farther, we don't know. How long after Bob starts will they be 10 miles apart? So that's their ending places. So we are looking for the straight line distance between Bob and Kathy. Now the two roads were at right angles to one another, so we're actually forming a right triangle. And if Bob walks at 2 miles per hour along one road, then in t hours, he will have gone a distance of 2 times t miles, and Kathy left 2 hours later, so she will have gone a distance of 3 times t minus 2. She will have been hiking for less time. Since the hikers are moving at right angles, we can use the Pythagorean theorem to relate their lengths. So our first length, one of the lengths of the legs, is 2t, so I'm going to square that, plus the square of the second length, and if we distribute 3 times t minus 2, that's 3t minus 6. We're going to square that as well and add, and that will be equal to the length of the hypotenuse squared, which will be 10. So 2t squared is 2t times 2t, or 4t squared. 3t minus 6 squared is 9t squared minus 36t plus 36, and 10 squared is 100. So now we have 13t squared minus 36t, and if we subtract 100, we'll have minus 64 equal to 0. So if we solve for t, which is the amount of time after Bob starts, then t is equal to the opposite of b. Remember, don't include the variables with the values of the coefficients here. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All of this can be entered in the calculator. So control divide for a fraction, 36 plus the square root of and use parentheses for squaring a negative number. Remember, the squared needs to go on the outside. Minus 4 times a times c all over 2 times a. And that gives us a t-value of 4. Or we have a second solution, which we can find by exchanging that plus for a minus. And that'll give us a value of negative 16/13. Since t is the amount of time after Bob starts, we're going to accept that positive solution, so that would be 4 hours after Bob starts. Will they be 10 miles apart? We can actually check that solution. After 4 hours, Bob will have gone a distance of 8. After 4 hours, Kathy will have only been traveling for 2 hours, so if we plug in a 4 for t here, 4 minus 2 is 2, times 3 is 6, and 6 and 8 and 10 are sides that will work in the Pythagorean theorem, since 6 squared plus 8 squared is equal to 10 squared.